Let's start with method 1, which is just memorizing the table of values. This method works well for visual learners or for people who don't mind trying to learn things by writing them down, covering them up, and then trying to recreate them. There are a few things to notice here which might help you to memorize the values. For example, the values for cos are just the exact same values for sine, but reversed. There are also zeros and ones on each row, and the same numbers 1, 2, and 3 appear in all of the fractions. Method 2, use a square root pattern. There's lots of variations of this particular method out there, but I find this one pretty straightforward to use. So what you do is you start with your empty table with your angles at the top and then sine, cos, and tan written down the side. Inside the table, you memorize what you need to write in there. You start with root 0 over 2, and then root 1 over 2, root 2 over 2, and so on. The numbers in the square roots are increasing by 1 each time, and the denominator's always staying as 2. Underneath, you remember that cos is just the reverse of sine. So you start with your 0 again, but this time on the other side of the table, and you increase by 1 each time going to the left. On first glance, these values might not look like the same ones we saw earlier, but actually they are. For example, root 4 over 2 is the same as 2 over 2, which is just 1. And that is the one that we saw earlier in that box. Root 1 over 2, root 1 is just 1, so that value is just a half, which is the same as what we saw earlier. To get the values for tan in this method, all you need to do is divide the sine values by the cos values. So root 0 over 2 is just 0, divided by anything is still 0. For this one, let's work it out underneath. So we've got root 1 over 2 divided by root 3 over 2. Thinking about dividing fractions in KFC, keep, flip, change, means we're going to keep the first fraction, flip the second fraction, and then change that divide symbol to a times. When we then multiply those two fractions together, we get 2 over 2 root 3. You can then cancel the 2's and you get 1 over root 3, which is the value that we saw earlier for tan 30 degrees. If you do a similar process for the other values, you will arrive at 1 and root 3. And that last tan value down there, tan 90, remember that's undefined because in that step, we're trying to divide by 0, which we know we cannot do. Before we move on, I'll just go back to that root 2 over 2 value and why it's the same as 1 over root 2. That comes from working with surds and rationalizing the denominator. So if you're starting with 1 over root 2 and you times the top and the bottom by root 2, you do end up with root 2 over 2, which is the same. Last method is learning the triangles. This involves you memorizing 2 different triangles and then working out the values from there using trigonometry or SOHCAHTOA. I'll show you how that works. You memorize this first triangle that has the angles 30 degrees, 60 degrees, 90 degrees, and then the side lengths of 1, root 3, and 2. And then if we start with 30, we're going to label the diagram using O for opposite, H for hypotenuse, and A for adjacent. And then we're going to work out sine 30, cos 30, and tan 30. So sine 30 would be opposite over hypotenuse using the SOH formula triangle. So that's going to be 1 over 2. Similarly, cos 30, C equals A over H, so adjacent over hypotenuse this time, root 3 over 2. And then tan 30, opposite over adjacent, so 1 over root 3. You can then do the same process for the 60-degree angle. You just need to relabel your sides accordingly. So now for 60 degrees, it's the root 3 that's our opposite and the 1 that's the adjacent. And then you work out your 60-degree angle values. And then we move on to the second triangle for the 45-degree angle. So we've got 2 45-degree angles and the side lengths are different this time as well. We've got 1, 1, and then root 2 for the hypotenuse. So it doesn't matter which 45-degree angle you use for your reference. I'm going to use the bottom one. So this would be opposite, hypotenuse, adjacent. And then you do the process for the 45-degree angle. The only downside to this method is that you can't get the values for 0 degrees or 90 degrees from looking at the triangles. So you'll just have to memorize these ones separately. Okay, so now we've seen some of the methods for getting to these trig values in the exam. Let's look at some examples where we'll need to use them. Example 1, we're given a right-angled triangle with some information on. So we've got a length and an angle there, and they want us to calculate the length AC. This looks to be a classic SOHCAHTOA problem, trigonometry problem. So let's use the 30-degree angle as our reference, label 20 as opposite, AC as hypotenuse, and BC as adjacent. I then usually write down the formula triangles, so SO, CA, and TOA. And then I look at what I've got in the question and think about which one I want to use. It looks like we have the opposite and we want the hypotenuse. Based on that, looks like we want to use SO or sine. So I then draw my triangle around that and use it as a formula triangle. We're trying to find AC, which is the hypotenuse, meaning H equals O divided by S. And in this case, O is 20. S stands for sine, so we're going to do sine 30. And then we remember that sine 30 is equal to a half. So we do 20 divided by a half, and that equals 40. Example 2. Show that the value of 5 sine 30 times cos 30 times 8 tan 30 is an integer. Remember, an integer is just a whole number. Okay, so it looks like we need to use our values of sine 30, cos 30, and tan 30. So either from memory or from writing down the table of values earlier in the exam or just before this question, we now know that sine 30 equals a half, cos 30 equals root 3 over 2, and tan 30 equals 1 over root 3. Now we're just going to multiply all these values together. We've got 5 times a half times root 3 over 2 times 8 times 1 over root 3. Now just going to multiply the top numbers together. So that's going to be a 5 times a root 3 times an 8. And then on the bottom, we'll have 2 times a 2 times a root 3. I then notice that the two root 3's cancel each other out, and what we're left with is 40 on the top and 4 on the bottom. So that then cancels down to 10, which is an integer. Last example, find the exact area of this triangle. Now, to get the area of a triangle, we need to do base times height divided by 2. Looks like we have the base here, but we don't know the height yet. We can work that out using Trigonometry SOHCAHTOA. So using the 60 as our reference, this will be the opposite, the hypotenuse, and the adjacent. Again, I like to write down SOHCAHTOA on the side and figure out what I have and what I want to help me choose which formula triangle to use. So I have A and I want O in this scenario, meaning we're going to use TOA. This time we want the O, so O equals T times A, and that is going to be tan 60 times 4 root 3. Tan 60, that was the root 3, times 4 root 3 gives 12. Now we can go ahead and pop that into the area formula. So area was base times height divided by 2. Let's do that. So base is 4 root 3 times the height 12 divided by 2 gives 48 root 3 over 2, cancelling down to 24 root 3 centimetres squared. And that's it. That's it for now. If you found this video useful, please do remember to like, comment and subscribe to my channel if you haven't already, and do share this with anyone else that you think might find it helpful. Thanks and see you next time.